With over 1 million members, we know what people can do when they come together. We are Rotary. We are people of action. Find out more at rotary.org/action.
Welcome to a special presentation from the Rotary Clubs of Jonesboro and West Little Rock. I'm Gary Higgins, President of the Rotary Club of Jonesboro. Rotary's motto is service above self. One way we serve is through outreach and education. This forum is a great way to share information during this pandemic. I'd like to thank District Governor Mike Benish for his support of these COVID-19 updates. I'd also like to recognize the outstanding contributions by Hatton Weeks, our host and moderator. Hatton is the Vice President and General Manager of KAIT-TV and is a member of the Rotary Club of Jonesboro. We are fortunate that he shares his years of experience in news and media with Rotary. Thanks for your time, and please ask questions. We want this presentation to be interactive.
Hey there, my name is Doug Shackelford, and I am President of the Rotary Club of West Little Rock. Our club, just like all of the clubs around Rotary District 6150, are where neighbors and friends and problem solvers share ideas and join other leaders to take action to create lasting change. In our club, we are so fortunate to have Dr. Jennifer Dillaha as a member. Dr. Dillaha is the state epidemiologist with the Arkansas Department of Health. She is also our 2019-2020 West Little Rock Rotarian of the Year. Our state leaders continue to lean on her every day for expertise and guidance, especially during this unprecedented time of pandemic. We are privileged to have her in our club and for her willingness to share her knowledge with Rotarians and other civic organizations throughout Arkansas.
And good afternoon. My name is Hatton Weeks. I'm a member of the Rotary Club of Jonesboro. Thank you for joining us for this live presentation. We hope you're staying healthy wherever you're watching this afternoon. After Dr. Dillaha goes through her presentation, we left plenty of time for your questions, so you can ask questions now, or you can wait until you think of them as you go through this presentation and ask them either on the Facebook Live or the YouTube chat windows. We'll get to as many questions as we can. We just ask that you keep them relevant to today's topic. Now let's bring in Dr. Jennifer Dillaha with the Arkansas Department of Health. Dr. Dillaha, a very important topic today. We're talking about a COVID vaccine, so take it away.
Well, thank you so much for having me today. As the medical director of the Arkansas Department of Health vaccine or immunization program, I've been learning about vaccines for years. So it's something I kind of eat, drink, and sleep. So I'm really happy to share what I have learned so far about the COVID vaccines. So to begin my presentation, I'd like to give you a little bit of an overview. You know, the governor has been doing press briefs every weekday for a long time, and now he has moved it to just once a week. So people are asking, well, how can I keep up? And so now is the time for me to, I want to give you an overview of what you can find on the Arkansas Department of Health website. So if I could have the slides, there we go. So I'm going to show this to you. So on this website, this is healthy.arkansas.gov. And then you scroll down on the first web page until you can find a big blue button that has to do with update and COVID-19 information, and you click on that button and you'll come to this web page. This will give you the total number of COVID cases, the number of confirmed cases, plus the number of probable cases, and then how many cases have recovered, as well as the trend line for the cumulative cases. There's a bunch of other information you can find along the tabs down here at the bottom. I'm going to click here on active cases so you can see how many active cases. These are people who are still infectious in the state. And as in the previous map, on this map, if you are to click on a certain county, then for instance, Craighead County, you can see how many active cases there are right now, how many of them are confirmed, and how many are probable. And then there's information on this tab about how many people have died and how many tests we have performed and so forth. So I think this will be useful information. I encourage you to take some time to explore the website and what's available. There's lots of helpful information on it. And for those of you that would like a little bit more local data that's more local than the county level data, I would like to see if I can scroll down here. This is a website for the Arkansas Center for Health Improvement, ACHI.net, and they will have COVID data that's available for you to view. But you can get data by the community or the city level, by the school district, and by zip code. And so this map right here is by school district, and this is the number of cases of all the people living in that school district. It's not just the students or faculty, but it will give you information at more of a local level. You can also put in your zip code or your community and get information, so you can get something that's maybe a little bit closer to home than what you could get at the county level. So now I will switch to my PowerPoint presentation. And so I want to just give an overview. What I'd like to do today is talk to you about COVID-19s. And there's too much to cover really in one presentation. So I'm focusing on today on how the virus infects cells, how the immune system responds to those viruses, and how we can use our knowledge about that response to make vaccines that would trigger a response without actually having an infection. And then talk about how you can learn more about the various vaccines being developed. So just as a reminder, the name of the virus is the SARS-CoV-2. It's the virus, but the name of the disease is coronavirus disease 2019, or COVID-19. And as a reminder, there's lots of coronaviruses out there. There's other coronaviruses that circulate among humans. They cause about 30% of the human cases of the common cold. And these are all named by letters and numbers. The ones we're more interested today are the ones that cause SARS and MERS and COVID-19, and especially COVID-19. So here's a model of the structure of the coronavirus. So you have the outer envelope, and it has these proteins sticking out, different ones. This one is an E protein. Here is an S protein, also called the spike protein, which is very important, that I'll talk about later. There's an M protein and an HE protein. And the spike protein is important in terms of developing the vaccines, because it is the way that the virus attaches to cells in order to be able to enter it. And so I'm going to talk through this diagram, and I'm sorry it's so small and hard to read. It's really more for me than you to help talk through about the different concepts in this. I took this from Nature. It's a highly reputable scientific journal. Here is the link to that if you find you want to go and look at it yourself. There's a very nice PDF if you want to print it out for yourself. But basically, the virus comes and it enters the human body by attaching to a receptor called an ACE2 receptor. And this receptor is present on a lot of cells in the human body. It's present on the cells in the nose and the throat, in the heart, the digestive system, the kidneys. Many cells have this receptor. It links to the ACE2 receptor through the spike protein. This spike protein is configured in such a way that it fits just like a lock and key with the ACE2 receptor. The virus enters the cell, it opens up and allows its genetic material, which we call RNA, to enter the cytoplasm or the liquid in the cell outside the nucleus. And this RNA codes for proteins that the cell, it like hijacks the cell to make these proteins and replicate the virus. The cell doesn't know it's doing this. It's like a Trojan horse. These RNAs look just like the RNAs that it would make for its own proteins. Then the virus leaves the cell and it's gobbled up by an immune cell. We call this kind of cell an antigen presenting cell. And these cells circulate. It's one of the types of white blood cells. It circulates throughout the body. And when it finds something like a virus that's not supposed to be there, it gobbles it up and digests it. And then it takes pieces of it and sticks it out on its arms and uses those proteins. So in this case, the spike protein, it presents it to the other cells in the immune system, especially the T helper cells, and says, looky here, this is what I found that's not supposed to be here. And it's communicating with the rest of the immune system to say, all right, get ready. We need to fight whatever has this protein on it. And so the T helper cell communicates with B cells, which make antibodies. And these B cells pour out these protein antibodies. And whenever they find a protein that matches the antibody, in this case, the spike protein, then it will kind of glob onto it and block that virus from doing anything. So the virus can't attach to the ACE2 inhibitors. It also communicates with cytotoxic T cells. And these T cells find human cells that have the virus in it. They're coming out on the surface, these viruses, so they can tell which human cells are infected with the virus, and it kills those cells so that it destroys the cells so the virus cannot replicate anymore. And then these cells go on, the B cells and the T cells go on to be long-lasting, long-lived cells that in some cases can last years and years, even a lifetime. And they constantly patrol the body. So in case they ever run into that one particular protein that it's learned to recognize, then it will be ready to remember what it fought before. It's a memory that the immunity has to then be ready to fight it, and it doesn't have to go through these steps anymore. It's already ready to go, and it gives the body kind of like a running head start for fighting an infection if it ever sees it again. So, let me back up just a little bit. So there are different ways to, in a sense, trick the immune system to gobble up this protein and present the spike protein on the arms of the antigen presenting cell without having to infect the body. And that's how you make these vaccines. So one way is to go ahead and give the vaccine just a piece of RNA that codes for the spike protein in a vaccine. So this RNAs, lots of copies are in the vaccine. They're injected into a muscle cell, like you get a flu shot in a muscle cell. This RNA from the vaccine then codes for this spike protein. The antigen presenting cells finds these spike proteins, gobble them up, and present them to the immune system to go through the process that I just described to trigger the immune system to have memory against this spike protein that the antigen presenting cell has shown to the rest of the immune system. That's one way of making a vaccine. These vaccines have been under development, this type of vaccine, let me say, have been under development for many years, and they're new in that they have not yet been licensed before as a vaccine. So there are two that are in phase 3 trials in the US, and if they are licensed, they will be the first RNA vaccines to be licensed in history. They've been studying them, I don't know, probably 20 or 30 years, but at least since I was in medical school, and I graduated in 94. So I think that these are going to be like the vaccines of the future, because you can make them very quickly. As soon as you know the genetic code for the virus, you can start making these vaccines. Another way to make a vaccine is to, in a sense, create a Trojan horse. So some of the coronavirus vaccines are using viral vectors. So these are other viruses, not the coronavirus, but another one. And in this case, it's an adenovirus. And these adenoviruses genomes, or the genetic material, has been edited so that these viruses cannot replicate. They can't multiply in the cells. Then what they do is they edit the genome in such a way that they take out the protein that would normally be on the surface of the adenovirus and insert the gene for the coronavirus spike protein. So this is an adenovirus with a coronavirus spike protein. And these adenoviruses infect are given to in an injection, and it looks like a virus to the immune system. These kinds of viruses don't cause illness, but the antigen presenting cell doesn't know that. It gobbles it up and then takes that spike protein and presents it to the immune system so that it can also develop a lasting immune response. And then the next kind I wanted to talk to is just a protein-based vaccine. So this is where you make the protein, and in this case, there's some of the spike protein and some of the M protein on the surface that I mentioned before, and they're grown or made artificially outside the lab, inside the lab, outside of the body, and put in the vaccine and injected into the human body. And then the antigen presenting protein gobbles it up and presents it on its surface, just like it had gobbled up a virus, it thinks, and then it triggers the immune response that way. So these are 3 strategies, and there's other strategies that are being used to make the COVID vaccines, but these are the 3 that I think are most likely to be successful and be possible for us to have vaccines in the US using one of these 3 strategies for the coronavirus vaccine. So I'm going to stop now and allow you the opportunity to ask questions about any that I've presented here or about a vaccine in general. I want you to know that there are probably 300 different coronavirus vaccines around the world that are under development, many more in the US than that. I think there's maybe 6, I've lost count, of that are in trials, phase 3, the late stage trials, going through the safety and the efficacy studies. And we may see them approved by the FDA in the near future. And then we would be able to provide those vaccines to people who want them. If you want to learn more, the New York Times has a really nice website for a vaccine tracker if you want to learn about them. And the Washington Post also has a very nice website that's tracking all the different vaccines that are being formed or developed. And it's easy to find, just NYT for New York Times Vaccine Tracker or Washington Post Vaccine Tracker, and you'll come to these sites and you can read more about them. Next time I'll talk about the clinical trials, how they're conducted, and how safety is assessed and efficacy is assessed for vaccines. And then after a vaccine is approved, how do we track the safety and make sure that people are not being injured by these vaccines, and how we track how well they work. So with that, I'm going to stop and take questions.
Thank you, Dr. Jennifer Dillaha, state epidemiologist with the Arkansas Department of Health and fellow Rotarian, joining us this afternoon, taking questions, talking about a COVID vaccine. And if you have a question, just ask it in the chat window. We'll get to as many questions as we can get to. And the first one up is from Rayanne Fields. Which of the 3 vaccines do you think will be the most effective?
You know, that is really hard to predict. And one reason is that the COVID-19 virus, the virus that causes that illness, it does not develop lasting immunity. When you get infected, you will be able to get infected again in the future. And so I think the ones that will be the most effective is the ones that's likely to develop the most sustainable immunity. And we won't know that for some years. Anytime someone is enrolled in a vaccine trial, they are agreed to be followed over time so that people conducting the study can see if their immune response wanes over time. So the ones that's going to be the most effective, I think, is the one that's going to develop the longer lasting immunity, and we won't know that for a while.
And when I hear words like or phrases like it could be whatever has the most is the most effective over a long period of time, that kind of goes into the next question of what's the timetable for when we could see a vaccine going to the public?
Well, that's also hard to predict. So we have a few vaccines now that are in phase 3 trials, which are the kind of the end of the investigation. So you do a phase 1 that shows that it's safe. Phase 2, you show that it's both safe and that it works. And then phase 3, phase 2 is with a smaller population. And then phase 3, you do the same thing with a larger population. And because you want to see if there's side effects that might be less common. So you use a larger group of people in case any side effects show up. And so there's some that are in phase 3, but they haven't recruited their full panel of patients, and they're looking for at least 30,000 patients in the U.S. So they'll have to recruit them all, and then you have to follow them for a period of time to compare the control group, the group that gets the placebo, the one that doesn't get the vaccine, with the ones that do, to see if there's a difference. Is the vaccine effective in preventing people from getting the virus? And that will take some time. So I would be surprised if we got a vaccine before the end of the year. Now at the health department, I've been really busy this week because the CDC released its playbook for how to plan for giving a vaccine if and when one is available. And our plan, we received the playbook yesterday, and our plan is due October 16th. And we're supposed to be planning as if a vaccine were to be available on November 1. It seems unlikely to me, but I'll be ready if it does happen. I think it will be next year sometime before we have those full recruitment, and they're followed for a period of time. And then the safety and efficacy are reviewed by independent people, not just the pharmaceutical companies or the vaccine developers, but other people review them for safety and efficacy. And then the Advisory Committee for Immunization Practices has to review it all too. And that's after the FDA has reviewed it and given some sort of an approval for it. So I think that this is, and we shouldn't hurry it, because if you hurry it, you may not get the kind of safety and efficacy study information data that you would need to have a realistic evaluation. So I think if everything goes really well by the first of the year, but probably not until later. And then, of course, once it's available, it'll take us some time to provide that vaccine for the large number of people that will need to be immunized. So I don't see us having a widespread availability of vaccine until the middle of next year.
Which at the same time is still an incredible timetable. Just the turnaround time is still, that's very fast in terms of a vaccine.
Oh, yeah. And we're just working really hard to make sure that we're ready if that can happen. I had a second thought about the first question, which vaccine will be most effective? Some of the vaccines may be more effective for some people than others. We know that as we age, that our immune response to vaccines wanes. So it could be that some of vaccines will work better in older adults, some would work better in younger adults. So we'll have to see about that also.
Dr. Jennifer Dillaha, State Epidemiologist with the Arkansas Department of Health, joining us this afternoon. Taking your questions. If there's a question you want to ask, just put it in the chat window. We'll get to as many of them as we can this afternoon. Appreciate Leslie Dennison for tuning in and watching this afternoon. She's asking, can we take all 3 vaccines at the same time?
Oh, I would not recommend that. And first of all, when we get the vaccine, we won't have a whole lot of vaccine initially. So we'll have to be thoughtful about who gets it first. And it won't be necessary to take all 3. So then what could happen is, you're using doses that someone else could benefit from. I can tell you that there will be 2 doses needed for these vaccines, and depends on which vaccine. You will need a dose 21 or 28 days after the first dose at a minimum. And the vaccine that you get for the first dose, you have to have the same vaccine for the second dose, because they don't work the same way. So I would not recommend having different vaccines at the same time.
Next question is coming in, and I assume they're talking about a control group here for the vaccine. Are all test subjects intentionally exposed to COVID-19, or is the exposure left to chance?
The exposure is left to chance. There are huge ethical issues about intentionally exposing people to COVID-19. I know that many people have mild disease, but even people with mild disease can have heart involvement and heart failure. And there are people who have lasting lung and heart damage from this virus. So I don't know that we could ethically ever intentionally expose someone to this virus. But of course, the people who are being enrolled, they want certain people with risk factors for being exposed. And so that may help us in terms of enrolling people who are likely to have some exposure.
I want to transition now, because we're going into flu season, and we know the flu vaccine, flu shot's important. But I imagine this year it's going to be that much more important. How important is it this year to get a flu shot?
Oh, I think it's more important to get a flu shot this year probably than it has been in our lifetime. Um, so, people can get the flu and COVID-19 at the same time. And I think that would be just a terrible illness to have both. We know that people who have COVID-19 can have lung damage. We know the flu affects the lungs. The flu can infect other organs too. It can infect the heart and the brain. But it's really the overall stress of the inflammatory response in the immune system. We know COVID-19 can cause blood clots, and people have died of a blood clot to the lungs. There's so much going on. So if you have both, that's just a recipe for disaster, in my opinion. Also, if you have gotten the flu shot, you're less likely to get the flu. It's not completely protected, but it helps keep people out of the hospital. So that lessens confusion, because some of the symptoms are the same. And so if you aren't likely to get the flu, then maybe if you have symptoms, or a lot of people don't have symptoms, then we won't be doing a lot of extra testing for COVID-19 because they had the flu or didn't get the flu. But the other thing is that even when people do get a flu shot and they get the flu, it goes a long way toward keeping them out of the hospital. And we really need to think about keeping as many people out of the hospital during flu season as possible. Our hospitals generally are stressed during flu season because there's so many related hospitalizations. I think last year we had at least 1,300 that were reported. There may have been more that weren't reported. And so we just don't want those hospitalizations on top of the COVID-19 hospitalizations. I think that would be something that's highly desirable for us to avoid in Arkansas.
Dr. Jennifer Dillaha, state epidemiologist with the Arkansas Department of Health. That's a mouthful for me to say, by the way. Yeah. Taking your questions this afternoon, and as Rotarians, we are about giving back to our community. And with the flu vaccine this fall, there is an opportunity for Rotarians to get involved. Tell me about that.
Oh, yes. So, the Arkansas Department of Health for many years has exercised our pandemic plan for distributing vaccine by doing mass flu clinics, like in an auditorium or a convention or a meeting place in the community. Well, we're not able to do that right now because we don't want people lining up to get a flu shot because we could spread COVID that way. So we're doing drive-through clinics or walk-up clinics at all of the local health units in Arkansas. And of course, with COVID-19, our staff is spread very thin. So we really would welcome volunteers at our local health units to help with the non-medical aspects of doing flu vaccination. For example, someone could receive the form that someone fills out or help them fill out the form, because we know there are a lot of people in Arkansas who do struggle with reading or filling out forms. Make sure the forms are completely filled in, because we have all kinds of data issues tracking things if people don't fill in their forms correctly. And then that prepares them to go ahead and get the flu vaccine. Well, this same process is likely to be used for administering a COVID vaccine if and when they're available in the future. So we encourage Rotary clubs around the state to contact the administrator of their local health unit to say they are available to assist with the flu vaccination efforts. It's like a practice run for when we get ready for COVID-19. If you can learn and develop a relationship with your local health unit to assist them, then when they're ready to do the COVID vaccine, they'll be so much more ahead of the game, so to speak, and ready to do that. And we do welcome volunteers, especially from Rotary, because Rotary has high quality volunteers. And of course, we know in Rotary that we believe in immunizations, and they need all the support they can get.
Well, Dr. Jennifer Dillaha, state epidemiologist with the Arkansas Department of Health and one of the busiest people in that building in Little Rock. We appreciate, as always, your insight.
Thank you very much for having me. I hope this is helpful. We'll talk more about next time about when we maybe we'll know more about having a vaccine or what vaccines have proceeded down the developmental investigations with the phase 3 trials. And I'll look forward to hearing more about it and sharing it with you.
And Dr. Dillaha mentioned several websites discussing the vaccines, the trials, and information on COVID-19. We're going to put that at the end of the presentation here in just a moment. But Dr. Dillaha, we appreciate you and everything that you and your team are doing for the state of Arkansas.
So thank you very much.
And we appreciate you at home or work, wherever you happen to be, for watching, asking questions, including Mr. Dennison, for everything that you do for our communities. Before we go, if you have a topic for a future conversation with Dr. Dillaha or another expert, just let us know. We're always looking to use this platform again in the future. So thank you for joining us this afternoon. This has been a special presentation by the Rotary Clubs of Jonesboro and West Little Rock. Stay safe and healthy.